equations of motion. You're probably familiar with the simplest of the equations of motion. Speed equals distance travelled divided by time taken. Strictly speaking, I should say average speed there. Okay, and we can use that equation, or if you prefer the triangle that goes with it, we can use the three equations that we get from the triangle. Speed is distance divided by time, in cases where there is no acceleration. It's harder to use the equation there though if an object is accelerating, and if it is accelerating we need to use one of two other equations. Now when we have an acceleration we have a change in velocity, so we're going to use the symbol u for the initial velocity of an object and v for the final velocity. So suppose, for example, I have a car here which starts off with a velocity of u and then it accelerates and its final velocity is v. Easy to remember because u comes before v in the alphabet. So we have u initially and v finally. You can see in this example that the change in velocity will be the final velocity v minus the initial velocity u. So if I'd gone from say 2 meters a second up to 6 meters a second, the difference would be 4. So the change in velocity would be 4. Now acceleration is change in velocity divided by time taken. So I can write that as v minus u divided by t. And that gives us the first of our equations of motion. A equals v minus u divided by t. But I might want to rearrange that. So if I multiply both sides by t, I get a times by t equals v minus u. And if I add u to both sides, I get u plus a t equals v. Or if I write that the other way around, v equals u plus a t. And that's the equation I would use if I was calculating the final velocity, giving the initial velocity and the acceleration. Suppose, for example, a car accelerates at 3 meters per second squared from an initial speed of 2 over a time of 10 seconds. What is its final speed? Well, you might like to pause the video, have a go at working out for yourself, and then hit play again to find out the answer. So in this case, the best way to do it is to write all of the variables. So we know the initial velocity is 2 meters per second. The acceleration is 3 meters per second squared. The time taken is 10. So if I put those numbers into my equation, I will get the final velocity is equal to the initial velocity 2 plus 3 times 10. So that means that v is equal to 2 plus 30. The final velocity will be 23 meters per second. Okay, so that would be how to use that equation of motion. Now sometimes we have to solve problems where we don't know the time involved. We just know the initial velocity u, the final velocity v, and the acceleration and the distance travelled. Now oddly enough, and this is I'm afraid rather confusing, we use s in this equation. We're going to use s to stand for the distance travelled. That's confusing, of course, because you would think that s would be speed, but just remember distance has got an s in it. So in this equation, u will be our initial velocity, v will be our final velocity, and a will be our acceleration. And if you do a little bit of mathematics, the equation that links these variables is v squared equals u squared plus 2as. Okay, v squared equals u squared plus 2as. So suppose a car moving at 5 meters per second accelerates for accelerates at a rate of 10 meters per second squared over a distance of 20 meters. What is its final speed? Okay, so you see in this question there's no reference to time. We've just got an initial speed of 5, an acceleration of 10, and the distance travelled of 20. So to work out v squared, I need to put those into my equation above. V squared equals u squared, so that's 5 squared, plus 2 times a, 10, times s, which is 20. The distance travelled is 20. So v squared will be equal to 25 plus 20 times 20, so that's 400, equals 425, which means that v will be the square root of 425. Okay, so get your calculator out for that one. The square root of 425 is around about 20.6 meters per second.